Welcome to the Explainer. So we're standing at the edge of a literally massive shift in how we interact with our tech, right? I mean, for the last few years, we've all gotten really used to AI being just a conversational partner. You type a prompt, it types back. But what actually happens when the AI steps out of that little chat box? Today, we're exploring this wild evolution. We are moving from mere chatbots to active, highly capable digital employees that can actually take control of your computer.
Okay, let's dive right into this. Think about the difference between having someone just hand you a recipe versus having someone actually go to the store, buy the ingredients, and cook the entire meal for you. That is exactly the leap we're making right now. It's a real game changer. We're moving from AI that just spits out instructions to an AI that directly orders those groceries, navigates your messy spreadsheets, and completely manages your desktop.
Here's our roadmap for today. First, AI takes the wheel. 2, the big 3. 3, the open source rebellion. 4, under the hood. And finally, 5, grading the agents. Let's get to it.
Section 1. AI takes the wheel. So, before we look at the shiny new products, we really need to understand the fundamental technology that allows these new digital interns to interact with our screens. The secret sauce here? It's what we call vision language agents. Now, let's break down that jargon for a second. Traditionally, AI has basically been text in, text out, right? But these are multimodal models. They don't just read back-end code. They literally see your screen. They visually understand the graphical user interface, the buttons, the search bars, the drop-down menus, and then they translate that visual understanding into actual mechanical actions, like physically moving a mouse or typing on a keyboard to complete a whole workflow.
Section 2. The big 3.
The commercial landscape for these agents is heating up incredibly fast right now. Now, what's really interesting about this comparison is the sharply contrasting philosophies between two of the absolute biggest tech giants. On one hand, we've got Anthropic's Computer Use, which is powered by their Claude model. And this is deep, local desktop integration. Claude acts almost like a ghost in your machine. It takes full control of your system to open apps, write code, run tests, and schedule things across your actual local desktop. But on the other hand, we have OpenAI's Operator. And OpenAI is taking a slightly safer cloud-based approach here. Operator is basically a web surfer. It lives in a virtual browser in the cloud. That means it doesn't eat up your local computer's resources, but its entire universe is strictly restricted to what it can do inside a web browser window.
And then we have the third flavor in this commercial race, which is Manus, developed by Monica.im. Manus is totally fascinating because it doesn't take over your personal laptop like Anthropic, but it's also not just a simple browser surfer like OpenAI. Manus is an autonomous virtual specialist that operates entirely within its own independent virtual environment. It bridges your thoughts to actions by handling really complex tasks, stuff like writing code, analyzing heavy data, browsing the web, but it does it all in its own separate specialized sandbox.
So, when you lay them all out side by side, the choice of which digital employee you hire really just becomes a question of scope and environment. If you need comprehensive, multi-application workflows, say you're pulling data from a local Excel file and pasting it into a local Word document, you're gonna lean toward Anthropic. But if you just need someone to aggressively fill out online forms or order office supplies without slowing down your computer, OpenAI's Operator is your perfect cloud-based worker. And then, if you need an independent worker to autonomously write up reports and execute code without risking your own local system, well, Manus provides that perfect middle ground virtual environment.
Section 3. The open source rebellion. Let's move to and see how this builds. Because while the tech giants are out there building these massive, polished products, a literal garage of developers are hacking together some absolutely incredible open source alternatives. Two massive projects laying the groundwork for anyone to build their own agents are Browserbase and OpenOperator. OpenOperator, for instance, is directly inspired by OpenAI's tool, but it totally democratizes the technology. It uses standard web developer frameworks, stuff you already know, like Next.js and React, to give everyday developers the exact templates they need. So now you can build custom AI agents that interact with specific web pages and extract exactly the information you want.
And they are doing this with just incredible efficiency. Take ProxyLite by Convergence.ai. This is an open source model with just 3 billion parameters. I mean, 3 billion, that's basically a pocket calculator in the modern AI world. Yet, it acts as a highly capable web agent by following this strict, step-by-step thought process. Step 1, observation, it just looks at the current web page. Step 2, reasoning, it decides what goal needs to be met next, like, finding a search button. And step 3, action, it executes the click. It literally just loops through observation, reasoning, and action until the whole job is done.
But there is a massive roadblock when it comes to open-source agents. General AI models are historically terrible at knowing exactly where to click on a screen. And that brings us to OmniParser v2. OmniParser totally solves this by taking a screenshot of a user interface and converting it into structured, mathematically interpretable elements. It basically draws these invisible boxes around every single button and text field, which allows models like GPT-4o, DeepSeek, or Claude to actually understand the screen. Developers are even using something called OmniTool, which is this neat Dockerized Windows system to easily plug this vision capability right into any AI model they want.
So the crucial point is exactly how big of an impact OmniParser actually makes. Look at this number, 39.6. On a benchmark test designed to measure how well an AI can find buttons on a screen, it's called ScreenSpot Pro, the standard GPT-4o model scored an abysmal 0.8. I mean, it was practically blind. But when you equip GPT-4o with OmniParser v2, its accuracy absolutely skyrockets to 39.6. Honestly, that is a game-changing leap. It literally transforms a simple text generator into a functioning computer operator.
Section 4. Under the hood. So we know what the agents do and we know how they see. Now let's take a peek at the actual mechanical parts translating these AI thoughts into digital clicks and scrolls. I want you to think of these three technologies as an engine stack. At the very base, you have Playwright. This is an open-source library from Microsoft originally built for testing websites. It's basically the raw mechanical muscle that allows a script to force a browser to click or type. Sitting right on top of that is Stagehand. Stagehand is an SDK that takes Playwright's muscle and adds a brain to it, specifically AI failsafes and intelligent manipulation of the web page's underlying code. And then finally, at the top, you have Browserbase. This acts as the hosting platform, giving developers the full, robust environment they need to deploy these autonomous web navigating agents safely and reliably.
Section 5. Grading the agents.
So we have all these amazing tools and models, but how do we answer the ultimate question here? Do these digital employees actually do a good job? And this brilliantly illustrates why old-school, multiple-choice AI tests are completely dead. You can't test a computer agent with a written exam, right? You need an interactive simulation. For example, we have OSWorld, which tests if an agent can survive in a real operating system, opening completely arbitrary apps. Then there's Web Arena. This drops the AI into realistic, high-fidelity web simulations just to see if it can fill out really complex forms. Web Voyager tests if the AI can navigate totally unfamiliar, brand-new websites it's never even seen before. And then GAI acts as the ultimate multi-step reasoning test. It really pushes the agent's general intelligence across games, online environments, and super complex decision-making tasks.
As these benchmarks get harder and harder, these AI agents are absolutely rising to the occasion. They're moving rapidly from being clumsy little experiments to highly competent digital colleagues. We are literally watching the computer interface transform, from a tool that you have to actively wield to a space where an agent just works on your behalf. Which leaves us with one final, pretty profound question to think about. When your computer can completely drive itself, what are you going to do with the passenger seat? Thanks for joining me on this explainer, and I'll catch you next time as we continue to decode the future.